My name is Peter Laz, and I am from University of Denver, faculty member, and Thor Andreassen is going to be the co-moderator for this session. This is themed around integrated credible practice. And so just to highlight the session focus, it's this explore ways to, need this to move. Explore ways to enhance credibility in modeling and simulation, and how those needs can be met via community involvement. So as far as a session, I'll just have a handful of slides to present as introduction, and then we have 3 speakers. And much like the last one, there'll be short talks around 10 minutes, and then we should have enough time to have a nice discussion. When I think about credible modeling, for me, I immediately go to the ASME V&V40 framework. That's kind of embedded in my thinking about credible modeling. In this is specifically focused on assessing credibility of modeling and simulation in medical devices. And in this, the models are motivated by their context of use. So that's a big piece, right, is how they intend to be used. There's a heavy component on verification and validation, also uncertainty quantification. And in this process, you can see in the flow chart, right, there's define the context of use. And there's this assessment of risk. And in that assessment of risk, you're thinking about the consequences of the decisions and then the influence of the model in that framework. And so what's really cool about this is that it's now been applied by a fair number of researchers around. And so you can see 2 examples here where they're doing design of a pedicle screw system, and then also in silico trials, and they're applying that ASME V&V40 framework. Another work that I'll highlight is this 10 rules of credible practice of modeling and simulation. This is a publication, and it lays out some similar ideas to the ASME V&V40. It mentions, of course, you can see there the context, right? Define the context clearly, context of use, and then also that evaluate within context. So that's thinking about verification, validation, uncertainty quantification, right? So we see those same terms come up here in this guidance. But what the 10 rules goes a little bit further to give you some insight into some best practices, right? So things like using version control, documenting appropriately, right? And then disseminating broadly. So I think these are some nice guidelines. I also wanted to highlight our NEHUB work that's in model reproducibility. So in this, we defined a context of use around knee model laxity, and considering both intact and ACL deficient knees. And in this work, we had 5 sites. They used the same data and same intent, but then used the modeler's preferred workflow. And we were essentially interested in evaluating some of the differences between the models that were created and the model results. And in this workflow, like in the early phases of model development, most of the differences were around sort of repeated measures kinds of things for segmentation. But as we progressed through to how we represented structures, the data that were used for calibration, we see larger differences between the teams, and that carried forward to then influence some of the results downstream. After documenting some of those differences, we've now moved forward in the next phase of this work, which is about developing consensus workflows. When I think about modelers, I think we're data hungry, right? This is some of the data and things that we wind up regularly thinking about. And it's the kind of thing where if you get an MR scan or a CT scan, you're like, yes, okay, great. And can I get the mechanical test data? Can I get the laxity data? If you get motion capture kinematics, it's like, yes. And where's the biplanar fluoroscopy data, right? Where's the EMG? Where's the pre and post, right? So this very much is this sort of yes and culture. And then I was thinking about sort of the range of models that people are working in. And we do like some work in all of these different areas. But I kind of tried to rate them on sort of model or data complexity and then the number of subjects. And so a lot of the really subject-specific finite element models, they tend to be smaller numbers of subjects, right? And then as we move towards musculoskeletal or statistical shape, we're seeing more and more subjects. And I think we could debate like where exactly these boxes might fall, but that's really not my intention. But I think we would all agree that the number of subjects that we have data for is definitely growing and growing, right? And we can also, I think, agree that AI and machine learning algorithms, they're going to eat all of this data, right? They're all going to be part of AI training sets. And I think when we know that the AI and machine learning models are only as good as the data they're used to train and develop them. So I think it really speaks to sort of the need for curated data sets and credible models. And that need is as important now as ever. So that's what I wanted to share as sort of some opening introductory remarks, and then would invite Amir to come up and present.